In this video, I'm going to show you interpolation method, Newton's forward interpolation method. Basically for numerical methods. Um, Actually, I have been recording this video earlier, and then the video was not getting recorded. Unfortunately, that's why I had to stop the video. Anyways, I've started coding this. I've simply included stdio library and conio library. Then I'm starting with int main. Well, for the Newton's forward interpolation method, we first have to design the difference table, right? So first let's have some inputs. um, I'm going to do this in a very simple manner. I shall try to do this in a very simple manner. Simple as in I shall be using this array type of thing instead of malloc, calloc, just to keep things simple. That's it. Then void inputs. This function, as you can see from the name, is going to accept all our input output. It's going to accept the inputs. So let's begin. Printf enter the number of terms. Well, I forgot to mention, but yeah, in this video I shall try to uh, make this an uncut video. um, I shall not cut portions from this video. It may take some time actually, because I don't have anything written in front of me. I'm going to code. I'm just think and code, and I have a book in front of me, which is going to help me with the formula and some data. If you don't know the formula and data, I suggest you first go through that. Well, let's begin. I need int I for I equal to 0, I is less than n, I plus plus. Okay, I'm going to need n here as well, the number of terms. Let's make it global. We may need it more than once in the function. In other functions we need it as well, maybe. Scanf %d comma ampersand n. So this is how we take the input of the number of terms. Now let's ask the user to enter the x terms. So I'll simply copy this part here. Enter the x terms. Okay. Then scanf %d comma x of I semicolon. So this is we are getting the x terms. Now similar process, we need to get the y terms as well. So let's do that. Instead of x, just replace it with y, and here instead of x again with y. So now we have the basic input function setup. Let's call this in the main function. What is the name? Inputs. So something strange happened actually. I had not configured my screen recorder, and F9 was set to stop the video, and instead of running our C code, this program just to test it, the video got stopped. So I've changed it, and let's begin. F9. Let's see the output. Okay, and the number of terms, let's say 2, and the x term 1 and 2. Oops, there's an error. Let's see what's causing this error. Scanning % x of I. um I don't know, 2 1 and 2. What's the problem? um it's a very simple problem, I know, because I've done this tens of times before. It never happened. X terms 1 and 2. What's the problem? Okay. um let's try to debug it. Printf %d slash n I. Let's see the iteration. Actually, I'm going to trace where the error is occurring. Okay, so okay, okay, there's some problem with the input, I guess. Why? Did I make a mistake in the scanf function? I better not. Obviously, I missed an ampersand sign. That's why. Small errors and you get stuck. Yeah, it's working. Okay, I've commented that part now. This is done, so inputs is done. Okay, now we have to make the difference table. Now the difference table, how to go about making the difference table? Well, if you observe carefully, um, the okay, let's have the columns like x and y, then delta y, then delta square y, and delta cube y. And delta y is y2 minus y1, and the next term is y3 minus y2. So I suggest you go through this concept first before seeing this video, or else you might get confused. Anyways, how to go about this? I'm thinking how to save them actually, because we're going to need the first term only. We need the first term. Okay, just give me a moment. um, um, what I can do is I can make another array of the same size as x and y, and I'm going to compute the difference, and I'm going to save it in that array. Then I'm going to, let's say, then I'm going to create another array and save the first element in that array. Yeah, that seems like a plan, because like if you see observe the difference table for Newton's forward interpolation, we just need the first term, the first the first terms of this, the first terms. Okay, just give me a moment. I'm seeing an example here actually, and I think there's some problem with this example. I'm not getting it actually. I mean, just a minute. Actually, to be very honest, I myself don't know how this thing works. I mean, I know somewhat, but still. Okay, so the first term is 3 point. Okay, second is, yeah, okay, perfect. Yeah, perfect, perfect. Okay. um um I think my game plan is perfect. Actually, the other example was a bit wrong, and I've done this before. Okay, let's see. Okay, the formula is something like p of x equal to a0 plus a1 into x minus x0. This x is the nth term that the user will input, plus a2 x minus x0 into x minus x1. Okay, okay, fine. This is going to work. No problem. No problem. It's going to work. It's going to work. Yeah. Okay. 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 Let's begin. So let's make the other array. Why is my phone not getting dark? Okay. Let's create the third array. Temp, um, 10, and the first element array. So fa. Let's name it again 10. Okay. Now let's compute the difference table. Void diff table. Now to make the difference table, um, the time complexity of the algorithm which I'll be using is going to be a bit high. This I can understand, but I don't think I have any other option. I can't think of any better algorithm. So let's begin with what we have at our hand. Um, let's begin with something like this. Int no means number of terms equal to n. Okay, then we I. Now while no while no is greater than 0, something will happen. And that's some if you observe, every time 1 2 3 4, then 1 2 3, then 1 2, then 1, every time the difference table, the number of terms, y term, delta y, delta square y, the number of terms is decreased by 1. So okay, so we're going to use that fact here actually. So for I equal to 0, I less than no I plus plus, then let's increase the font size a bit. Then let's calculate the difference. Well, I is less than no. Let's make it no minus 1. I may tell you why. No minus 1, and here let's um actually let's make everything float. Int will be a problem actually. This let this n be integer, but let everything else be float. Many of the examples, they were having float actually. It's better to use float. Okay, I equals 0, I less than okay, then calculate difference and what's the name, this. Okay, so um, float, I can't type today, float diff, then diff equal to y, y of I plus 1 minus y of I. Why this is the reason? Because it's y2 minus y1, then y3 minus y2, and so on. So that's why I have written for I equal to 0 to no minus 1. This minus 1 will guarantee that we don't try to access an element out of the range. Okay, so this is how we get the difference. Now um, now temp of I equal to diff. What's this? Temp of I equal to diff. Okay, so this is how we're getting it. Then and another pointer actually for index, let's let it be 0 initially. Well, this index is actually going to be the index to the final array that's going to have the topmost element of all the different table columns, like the delta y and delta square y is going to have the topmost element. That's what we want. So initially it's 0, then temp of I equal to diff is going to have the temporary okay, it's going to populate the temporary array. Now after this, let's make sure we reduce no by 1, no minus minus. Okay, now we have to do something like actually I'm thinking of one thing, like if there is only one element now, okay, and that means no is equal to 1. If there's only one element, then this part of the code should not be executed, will not be executed, because no equal I equal to 0, I less than no minus 1, and no is 1. Okay, so it's 0 minus 0, right? Sorry, I equal to 0, I less than no minus 1, no is 1 now, 1 minus 1 is 0, and I plus 1 would mean y. Okay, it's going to encounter an error here. I hope you understood what I'm trying to say. Like if no equal to 1, then no minus 1 equal to 0, right? And it's going to access the I plus 1th element, means the I means the second element is going to access, but it's only one element, so it's going to encounter an error here. So actually what we must do is we must enclose this in a condition such that like um just a minute, no minus I equal to um I is 0. uh okay, it's going to be no minus 2. That's going to solve our issue actually. No minus 2 doesn't solve our issue. if there are four terms, means n equal to 4. Yeah, no minus 2 can solve our issue. So if no is equal to 1, then 1 minus 2 is minus 1. Yeah, it's not going to get executed. But in that case, we have to populate the table in another man. Okay, so if no is equal to 2, then number of elements is 2, then 2 minus 2 is 0. Yeah, it's going to work if it's 2. Okay, no minus minus. Now we're going to need a condition. If no, okay, I'm going to decrement no later. So if no equal to 1, then what? Then if no is 1, then uh, this one, the final array, the final um, difference table, that's what we need actually. So fa of index plus plus equal to y of 0. This is what we need. Okay, I think it's okay. Then else, if it's no is not equal to 1, then same thing here, but instead of y is going to be 10. I know I can't explain this because I have the example in front of me and it's not in front of you, so it's going to be a problem. It's becoming a problem actually. um like, I hope you can understand this. Okay, what I'm going to do is I'm going to attach an image of the example which I am taking reference, and you can put up this image side by side, and you can refer from this. So fa of index plus plus equal to temp of 0, the first element of temp every time. Now what we have to do is we have to modify our y array. Why? Because temp is the temporary array and we have to modify our y array. Now I'm modifying it. You may not want to modify, you may want to keep the data, but I don't think I will need the data, so I won't worry about modifying it. I'm going to modify it actually. So let's begin. Again, a for loop here. For I equal to 0, I is less than no, I plus plus. Will this be no minus 2? I less than no minus 2 or no minus 1? No minus 1, I guess. Like if no is 0, then no is 1, then 1 minus 1 is 0. Means if I is less than 0, yeah, it's going to work. No minus 1 is going to work. Like, okay, if no is 1, okay, if no is 1, then this part becomes no minus 1, means 1 minus 1 becomes 0. Okay, so so the condition is I is less than 0, but I is equal to 0 at the beginning, so it fails. So it's not going to execute for I equal to 1, and this part is going to execute it. No is equal to 1, it's going to get executed, and rest is all okay. So I equal to 0, I less than ny plus plus. This is working. Now we have to sort of interchange the elements, not interchange, actually copy the elements from temp to the y array. So y of I equal to temp of I. Okay, this is it. It's going to change it now. Okay, no minus minus. Yeah, I think the difference table is going to get created in this way. Let's try to see this effect. So actually, let's print the difference table now. Print it. The not the difference table actually will put the first elements of the table which we will need. I mean the from the equation, the a0, a1, a2, that one, that we're going to print. We're going to print the constant terms are, and for I equal to 0, I is less than, how many will it be? If there are n terms, then there is going to be well, how many? 1 2 3 it's 1 2 3 4. There are 4 terms, and the number of constant terms is going to be 1 2 3 4, so it's 4. Okay, so it's 4, I guess, right? 4, 1 2 3. Okay, so it's going to be n less than n, then I plus plus. Now let's print them. Printf printf %d sorry %f, then fa of I. Okay, now let's run this actually. Guys, don't freak out if you see a bunch of errors now. I'm afraid it's okay. I don't have any errors at this moment. I thought I will get more errors. Anyways, enter the x terms. The x terms are I can see 0, then 1, then 2, then 3. Then the y terms are 3, then 6, then 11 and 18. The constant terms are 3 2 0 0. Let's see, it's 3 3 2 0. So 3 3 2 0. So it made an error. I can see that. Okay, what is there? First is 3, then it's going to be 3 again, theoretically. Let's try another example before jumping to conclusions. Here it's going to be 3 terms, and it's 2.7, then 2.8, then 2.9. The y terms are 0.3704, 0.3571, and 0.3448. Okay, the first terms coming negative. I have no idea why. The second term, okay, there is some problem obviously. Let's fix it. I'm going to pause this video and I can record it, because I'm afraid if I try to record too much at once, it may encounter some problems. So I'm going to pause the video, stop the recording, save the file, and again start recording. Okay, the recording is going well till now, and let's hope it's this way till the end. Okay, we had encountered an error. Let's find out. Actually, the best way to do that is let's print it here. So printf new line %f, then fa No, no. Uh, um, okay. Here, then it's going to be this way. Fa of index minus 1 equal to Fa of index minus 1. Okay, it's the same thing here, and let's run it and let's check if it's working or not. So again, come on, you can do it. Okay, yeah, here you go. The axes are 0, then 1, then 2, then 3, and y is 3, 6, 11, and 18. Oh my god, what is this? Oops, I think, yep, I missed this. It's %f. We gotta close this, and again, come on, hurry up, terminal. Yeah, then 0, 1, 2, 3, and for the y it's 3, 6, 11, 18. Okay, so fa of 0 is 3. First element is getting in is 3, then again it should be 3, but why is it? Oh my god, that's the reason. Okay, I'm going to tell the reason. First, let me just solve it, and then just hold on. I'm going to tell you what I'm doing here. Again, 4, 0, 1, 2, 3, then 3, 6, 11, and 18. Okay, okay, what's this? This 3 to 0 is coming. No. I'm so sorry. 3, 6. Oh gosh. 0, 1, 2, 3, then 3, 6, 11, 18. Okay, the first element is 3, then 3, then 2, then 0. Perfect. Okay, so what was the problem? Let's comment this out. Okay, like if you observe the first element, okay, the first element of the difference table is the first element of the y array without any manipulation. The first element of this array is the first element of the difference table which you will be using. Okay, so that I have not been doing. As you can see here, I have done what I had done is I had done while no is greater than 0. It should be 1, not 0, because the first element is the first element of the y array. So this is constant. So let's take it outside any type of iteration. So it's constant. So one step's already gone. So it's one less step. So if no is greater than 0, what we have done earlier, now it's going to be no is greater than 1. So that's the reason why I changed from 0 to 1. Rest is all pretty simple. So this was the thing. Actually, the first element was constant. Okay, so this is done. We successfully created the difference table. Okay, now let's try to let's make a function that's going to do our job, like that's going to calculate the x minus x1. Okay, let's see it. That's going to calculate the x minus x0, then x minus x0 into x minus x1, and so on and so forth. It's going to do that. So what I'm planning is, it's what I'm going to do is I'm going to multiply a0 into this function, and I'm going to pass I, the iteration, as a parameter. And if I, okay, yeah, if I is 0, it's not going to do anything, it's going to return 1. So a0 into 1, the constant term as a0 into 1, it's going to be the first element. Then okay, if it's 1, if it's 0, it's going to return 1. So let's name it, it's going to be float multiplier um, I need the x term, so yeah, I'm going to put it like this: int x comma and index. I need the index, that's why okay, so as I reasoned here, so like if index is equal to 0, then return 1, else we have to do something else. Else we have to multiply from x minus x0 into x minus x1 into x minus s2, and so on and so forth. Sorry, x minus x0 into x minus x1 into x minus x2. And this we are going to do, my friends, in a loop. And actually I'm thinking how I'm going to go about this. Just give me a minute. Okay, float mul equal to 1. This is going to store the multiplication. Then I need another variable, int I, of int I. Now for I equal to 0, I is less than equal to index, I guess. A is going to be equal to index, less than equal to I plus plus, then what? Then it's going to multiply. So mul into equal to something, and that something is going to be, well, my goodness, I think I need 2 loops here, not 1. Okay, so mul into this something, and what is this something? This something is, okay, what is this something? Yeah, now it's x minus x0. So yeah, yeah, it's x minus x of I. Let's not write x here, let's write xn, because we have an array x and it's going to clash actually. Xn minus x of I. So multiplication into means mul equal to mul into xa minus x of I. This is x0, then x1, then x2. Oh, this is perfect. So let's return mul. return month. Actually, I can't test this function as of yet, so I gotta go forward with the next function. What do I need now? I need to return the value. Okay. What do I have? I already have the constant terms, the a0, a1, and here with this multiplier I can get the multiplier terms. So what am I lacking now? I'm not lacking anything. So I can go with our solution. Before I jump to the solution, let's wait and let's see. Okay, so if there are three terms, the loop is going to run 3 times. Fine. If there are 4 terms, it's probably going to run 4 times. So in the book it says, what does this say? 1 2 3 4 5, and there are 1 2 3 4 5 6 7 terms is going to run 5 times. Why? Because maybe the following terms has become so insignificant it does not matter. So yeah, if there are 3 terms, we're going to run 3 times. So if there are n terms, we'll run n times. So let's code the function now. It's going to return something, so float answer, maybe for answer, int xn, the xn term. That's it. I don't need anything more. Then I need I for the loop. So for for come on, for I equals to 0, I less than n, I plus plus. I need null also here again. Not null, I need answer float answer equal to 0 initially. It's going to be answer plus equal to, okay, answer plus equal to fa of I. Let's enclose this within a pair of braces, I mean brackets, fa of I into multiplier. Let's just copy the name so I don't misspell the name here. Multiplier xn comma the index. The index is I in here. So I guess the answer is going to get calculated in this manner, and let's return the answer now. Return answer, and let's hope everything goes according to plan. So printf what's xn? Okay, so printf enter the xn term, scanf %d %f comma ampersand xn semicolon float xn. I'm feeling hungry also, my stomach's rumbling. So scanf percent f and percent xn. Now let's print it. Printf. The answer is percent f, and it's going to be the function name is also answer. So answer xn. Okay, again fingers crossed, and don't be scared if you see a ton of errors here. Okay, here we go. The beginning of errors. What's the error? Expected semicolon before scanf. Of course. Okay. Yeah, I missed a semicolon here. Oh my goodness, no errors. Okay, so let's try our luck. Okay. See. Okay. Number of terms is, I give 0. It should be 4. Come on, terminal. Number of terms is 4, then 0, 1, 2, 3. The y terms are 3, 6, 11, 18. So 3, 6, 11, 18. Constant terms are 3320, and it's also 3320. Okay, so the xn term they have given 1.1. So let's try 1.1, and the answer I'm getting is 3, and the answer which they got is 6.41. So I messed up somewhere. Don't worry, let's dig into it. Where did I mess? Whatever. Come on. It's running a bit slow here actually. This is a virtual machine. I'm downloading some stuff here. That's why. I think the best way to track errors is if we can have a look at what the computer is doing. So answer plus equal to this thing, when we are saying let's just print this thing, then we should have a clear picture what's happening in the calculation. I'm going to do that actually now. Printf fa of %d into not like that. It's going to be okay. It's going to be %d, no, %f, yeah, multiplying again %f. The first part is going to be fa of I. The second part is going to be multiplier of xn y. Just hope it works, and let's remove other printf statements. The constant terms are so and so. I don't need this anymore now because I know it's working. So let's run it. 4, 0, 1, 2, 3, then 3, 6, 11, 18. The xn term they have given 1.1. Okay, so first, okay, 3320. So the a term is okay. As you can see, this is okay. It's a constant term. This is okay. 3320. Yeah, 3320. There's no problem with this. The problem is with the multiplier thing. And let's start a notepad. And a calculator, I guess. I'm very bad at calculations. A computer is hell slow. I hope the size is good for you. Okay. What do we have here? Okay, we have to do is for the first term it's going to be nothing. The second term is going to be, oh my god, I think I made a mistake here. uh the multiplier is going to be, oh my god, less than equal to index division, uh, index minus 1 actually, because like for this first is a0, then a0 into the multiplication thing, so that time index is, okay, index 1 that time, right? Come on, and there is 1 at a time here. This 1 is getting past this 1 and it's less than minus 0 to, yeah, it's going to be minus 1, I guess. Let's run it and see. I think it's going to be minus 1. Come on, terminal, open up. It's not terminal, it's command prompt. Terminal is for Linux and Mac, I guess. Come on, come on. Okay, that's, after that, what should I check? I should do the calculations actually, because it's 1.1 minus the first term. That's it's external white. Oh, fudge. No, yeah, I've done properly. It's externally. Yeah. Okay, what the hell is it? Come on. Oh, it's here. No, should I have to close this? That's why. 4, 0, 1, 2, 3, then 3, 6, 11, 18. 1.1 is, thank you. Answer is I'm getting 6, and the answer which they are saying is 6.41. So most probably, maybe there's some truncation error, I guess. Everything, if I convert to float and try, I don't know, let's see. This accent, this is all float, not this. Here, something here. F is also float, I guess. So why I'm getting 6 there? Let's do multiplication actually. So first it's going to be 1.1 minus 0, that's 1.1. So it's going to be, first term is 1.1, then it's 1.1 minus 0, that's 1.1, into 1.1 minus 1, and 1.1 minus 1 is 0.1, so 0.1, and which is equal to, I don't know, 1.1 into 0.1 gives us 0.11. okay, 0.11. Then third term is 1.1 into, no, it's oh, the fourth terms, yeah, third term, yeah, it's 1.1 into 0.1 into 1.1 minus how much, 0, then 1, then 2, 1.1 minus 2. Yeah, it's 1.1 minus 2, and what's 1.1 minus 2? 1.1 minus 2 gives us minus 0.9. So minus 0.9 into 0.1 into 1.1 gives us minus 0.99 equal to minus 0. How much was it? Okay, 0.099. So the first term is 1.1, then it's 0.11, then it's minus 0.099. Okay, with this data, let's run it now. 4 0 1 2 3, and it's 3 6 11 18, 3 6 11 18. Xn is 1.1. Okay, it's 1, then 1, then 0, then 0. Obviously there's some mistake here, it should be 1.1, but it's giving us 1. So there's a problem with the multiplier function. Obviously, let's figure it out. Int x and y, int float x, and rest is all okay, I guess. Let's run it. 0 1 2 3 and 3 6 11 18. It's 1.1 1 1 0 0, again the same thing. Okay, what's the error? I guess I have to print this as well, maybe. Okay, let's print this as well. What else to do? %f minus %f, and the first one is going to be xn, and second one is going to be, what is going to be, x of I. Printf in multiplier. It's NINE, I know. Leave it, it's not going to hurt us. 3 6 11 18 is 1.1. Okay, in multiplier, first time it's not going to do anything. It's 1. What's this? 1 minus 0. Why? Let's make things a bit more clear. First was in, now it's out. 4 0 1 2 3, then 3 6 11 18 1.1, and first one is only going to be in and no out. In multiplier, again in multiplier, but why no out here? If index equal to 0, then return 1 1, else so as you can see here, okay, this definitely some problem with our multiplier. Like, I'm really confused actually. So much data. These three are for one set. What is this for again? What's happening? Okay. Fuck it. Find. Come on, keep finding this. Uh, um, let's do something here. Okay. Actually, I'm getting confused myself. Okay, out multiply I've written twice. There's no reason for the second one. And let it be only one. And after that, let it be have two. So I'm getting confused myself. 0, 1, 2, 3, then 3, 6, 11, 18. Xn term is 1.1. Just hold on, I just got a call. Okay, the call disconnected. Just wait. In multiply, out multiply, n. I'm not worried about this now. I'm just finding that line. Okay. The answer is then answer, right? Answer is then answer. And okay. Okay. There's some deep shit going on. Let's give some stars here for our star program. Zero, 1, 2, 3, 3. What was it? 6 and 11, then 18. 18. Come on. 1.1. Where are those stars? Our stars. Yeah. N multiplier. Then N multiplier. Okay. I don't understand what's this, like 3 into what's this. Well, what's this multiplication sign? Okay, this one answer. Okay. I don't need this. In multiply, then nothing. Okay, in, then out. 1 minus 0. Okay, here's a problem. It's getting 1 minus 0, but it should have been 1.1. Okay, this is a problem. Okay, 0 then 1, then 0, 1, 2. Okay, only problem is with xn. The problem with xn. Int xn. That's the fucking reason. Idiot I am. 3, 6, 7, 10, 1.1. 6.52 is the correct answer. The book is saying 6.41, but they have left out some of the terms because it says that the more you go, like delta cube, delta to the power 4, it won't matter actually, because how much charge do I have? 78%. Okay. It will not matter, it will not matter much. Okay, let's try another example actually, just for clarity's sake. Number of terms is 3, and here x is 2.7, then 2.8, then 2.9. now y is 0.3704, 0.3704, 0.3571, 0.3571, and 0.3448, 0.3448. And we have to find is, how much do you have to find? 2.72. 2.72, and the answer which they have given is a different answer. Okay, they have given a different answer. They have given minus 1.3 into 10 to the power minus 5. Definitely I'm not even close. Okay, what's the issue? Okay, is a multiplier function working? So 2.72 minus 2.7. Okay, then 2.72 minus 2.7 minus 2.8. Okay, 2.72, 2.8. Yeah. Okay, our multiplier function is working perfectly. There's no problem with the multiplier function. Okay, this much is okay. So what's the issue then? We have to find the issue. Now we have to uncomment this line. Let's see what they're giving, and let's comment out these lines, because I don't need these lines anymore now. 3, 2.7, then 2.8, then 2.9, then 0.3704, 0.3704, 0.3571, 0.3571, 0.3448. We have to find 2.72. 2.72. It's 0.3704. That's okay. The second term is 0 minus 0.13300. Yeah. Third term is 0. Okay, there's a negative sign in the book, but I'm getting a positive here. Okay, it should be negative. Yeah. So there's a problem here. The first term is, oh, okay, 2.7, and it was, the extent is 2.72. Yes. Okay, yeah, it's 1. Then it's, yes, 0.2. Then the third thing is, let's have a handy calculator. 2.72 minus 2.8 minus 0.08 into 2.72 minus 2.9 into 2.72 minus 2.9 is 0.144. So there's an error here as well. I guess. What am I doing? No. Come on, focus. 2.72 minus um yeah, it's going to be 0.02 into 2.72 minus 2.8. Sorry, it's going to be 2.72 minus 2.8, okay, into 0.02. Yeah, so multiplier function is okay, so there's a problem with this one. There's a problem with this one, I guess. The problem with this one. Does this have a problem? uh, it's a constant, okay, 0.37, okay, minus 0.133, and then it should be, yeah, it's okay as well. I'm sorry, it's okay as well. It's 0.37, okay, then minus 0.133, then 0.001. It's, yeah, it's perfectly fine. uh, then is there some problem with the multiplication, I guess, because like this constant terms are absolutely fine, and its multiplier terms are also absolutely fine. So the only thing that can happen here is the answer is getting calculated um wrongly, I guess. So let's find out. It's very simple. It's equal to percent f ans answer. We will get the cumulative answer, but still it's okay for us. Actually, the book contains a lot of errors, so I can't swear by this book. Actually, let's try a different example just for our, so for simplicity sake. 4 terms, and it's 0.1, then 0.2, 0.3, 0.4. Y terms are 1.005, 1.020, 1.045, 1.081, and we have to find 0.16. And yeah, I think it's perfect. Yeah, it's working, I guess. That example had some problems, that's why it was not coming. Yes, okay, the book also says the same thing. Let's try one more example. Number of terms here are 1, 2, 3, 4, 5, 6. Oh my god, 6 terms. 0.20, 0.22, 0.24, 0.26, 0.28, and 0.30. Y terms are 1.005,
659 1.669 1.680 1.691 1.702 and 1.713. We have to find 0.29. The answer which they are saying is 1.70, and we're getting 1.65, so it's pretty close actually. Okay, the other problem had an error. Okay, I mean error, I mean the book had an error. Okay, I'm getting 6.65 and they're getting I'm sorry, I'm getting 1.65 and they're getting 1.70 because they have not done the entire calculation. They have done only the 3 steps and we have done the entire calculation. That's why we're getting a more accurate value. So this problem is solved, and perfectly it's perfectly good answer. And yeah, this is it for this video. I think I'm going to make more such videos on numerical methods. Let's see. If you like this video, do hit like and do share it with your friends. Sharing is caring. Thank you.